All right, good morning, everyone. Welcome back to our third installment of the lecture series AI BDS 1. So the first thing I'm going to do, because we had um, last time we went kind of through a lot of topics, a lot of things. So let me summarize what we did and let me use our structure to show you what we did, where we are, why we did it. So this will be like the first minutes. So instead of having like today a creative AI talk, we're gonna sort out our topics a little bit because uh, up to here it's pretty like mixed what I have to do with you, but from here, like from business understanding, it's pretty structured, so we don't have to waste a lot of time. But now at the beginning, there are quite some topics that I need to like talk about so that you know what we are doing and what we are not doing. So the purpose of the topic 0 and the topic 1 is to show you what we are focusing on of a large set. So our large topic is AI-based decision support. However, we cannot shed light on every aspect of this. So this is why we kind of use these things, but as you can see, we do not do everything. Like some of the things we do in AI BDS2, some of the things we won't do at all, and some of the things I will just briefly talk about. So basic thing is that what we learned is that the business understanding, which we will talk about today in detail, kind of has a large meaning also within the realm of topic 0 and topic 1. So it's about the task, what we need to do, what we actually focus on in a large chain of tasks. So what we did was basically we started out and said, okay, we want to focus. There are a lot of things we can basically do, right? So there are a lot of types of analytics. So we said, okay, there's descriptive analytics, like in controlling, we look at the past, we do some BI, there's some diagnostics. So this is basically statistics. Then there's predictive analytics, and prescriptive analytics is actually when you use a lot of information to actually make decisions. Like you can also automate this. This could also be done by an AI, right? So for example, generative AI, they actually decide what pixel to put into the generated image or the music, right? But with your input and with other information. So we said we are in this course, right? And also in the next, so AI-based decision support, we are focusing mostly on predictive analytics, right? So will be our focus. However, we will here and there dip into descriptive and prescriptive analytics. We will not dip into diagnostic analytics since this is like classical statistic. You've already had that, you've heard that. There is no need for me to actually dive into this. I will kind of distinguish what we do from diagnostic analytics because I feel this is important. However, we won't dive into this. So we will need descriptive analytics mainly in our next chapter, which is data understanding, where we need to describe the data to learn how we can use it for prediction and also how we can prepare the data, because exploring the data will be a helpful input for detecting problems with the data that we need to fix before we can actually use the data to build a model, right? Because as you said, if you put in like data that's not very well orchestrated, that has not the information that you need, that has some errors, that has bias, and so on. We've talked some of the problems on a general level, but we will talk more deeply about the problems in data understanding and data preparation. So, as I said, there's a lot of things you can do in AI-based decision support with data, but the thing where AI or machine learning shines is predictive analytics. You remember the analogy I said with the learning. So this is true for when you build a model. Like in descriptive analytics, you usually don't have models. You just have like statistics, you have numbers, you explore them. So, I mean, you can automate this, but there is no real AI here involved. Usually diagnostic analytics, the same. It's like statistical model. You have to have a lot of manual input because you want to like put in some theory that you want to check. And prescriptive analytics is like the pinnacle where you actually make the decisions. You remember we had this example right here where you choose where here we actually choose the action based on information. And of course, as an input for prescriptive analytics, we can use like predictive analytics, like what will happen if we do that. So we can make a prediction. The prediction then needs to be good. Otherwise, we choose the action based on information that is not valid. And this is like a very important thing that you might encounter or you might have heard of. So when we make a decision, we make it based on information, and we hope that these information are like correct, valid, whatever you want to call it. And you see this discussion come up a lot with like fake news. We had it in the COVID era where people were misinformed about health risks, about vaccines, about all these kind of things, and maybe they delve into some subgroups. They were where misinformation was spread. The same as like today when we look at everything that's going on in the world, we have a lot of misinformation from a lot of sides. So it's not like one or the other side, but we have a lot of misinformation, and then we make decisions like, what do we discuss? Who are we for? Who do we vote for? Based on information. And if these information are not correct, then we will make the wrong decision. So, for example, here we had this whether we produce something or whether we produce something or whether we don't produce something. So in this case, it's basically like we have some things that we can actually do. So if something is successful, then it's nice. If something is not successful, then there is a problem. And if this information is false, for example, if we predict a probability of 99% that it will go well, then we can discard this. But if the probability is actually in this situation more closer to like 50%, then this will be another problem, right? So I have to adjust my behavior, my decision behavior. So this is why prescriptive analytics is really important, and you will see this a lot when in the ORBA course, in the master study course of ORBA, and all the courses. Like this is basically prescriptive analytics is basically involved around making decisions. So this is OR, operations research management science. Like how can we choose the correct action based on other information. So, okay, so this was like a recap. And as I said, really important, we focus on predictive analytics. Now, in predictive analytics, there are also like two approaches that use machine learning. Like when I talk about predictive analytics, I talk about predictive analytics with machine learning, as you can see here. And then we said, okay, there are two modes of learning. So then I gave you this analogy with the little child and the parking lot. And this was actually an analogy for supervised learning, because in this course, we will be dealing with supervised learning, because supervised learning is, yeah, well, more difficult, and it's the base foundation of deep learning. There are also, don't get me wrong, there are also deep learning modes with unsupervised learning. So this is just basically two concepts, right? But it's not like two concepts that lead to the same result, right? So this is very important if you think about this. So when we go through it, let's go away from the analogy and talk the real technical terms. So as a summarization from last time, supervised learning problem mean we have training data. Now, it's important that the training data in supervised learning consists of features, which is we call X, right? So the variables X, or the data matrix X. So this is the part of your data table where all the variables are, like, for example, weather, time, traffic conditions, whatever, right? And then there is also the Y variable given in the training data. So there's also basically the correct solution we want the model to put out. So there's maybe the time a truck needs to go from A to B. This could be like the time we connect with X. And then actually the machine learning algorithm will train based on that, right? So the machine learning algorithm will train based on what we get as input and the correct solution. And then the machine learning algorithm should be able to get new input data that is only X now, like, as I said, weather conditions. So we say, okay, this is the weather condition, this is where we need to go. And then we need to predict, predictive analytics, how long the truck will take to go from A to B based on all the variables we put in, right? And the model will have learned based on the past. Okay. So what we give as a training data, so supervised and unsupervised learning, the distinction is based in the training data. So we give X and Y here. And in unsupervised learning, well, we only give X. So you can see here, we give the information, which kind of class it is, and then we need to distinguish between the classes. And here we have to kind of find similarity among the data instances, but we don't really have like classes, or we don't really have a Y variable here. So this also means that unsupervised learning, sorry, usually has a different kind of task than supervised learning. So it's not like you can do the same thing with unsupervised learning that you can do with supervised learning. There is some overlap where you can achieve both. For example, you can do anomaly detection with both, but then anomaly detection is not really a data mining goal. It's like this would like be a business goal. But if you formulate the goal, you can, for example, say, okay, I'm gonna group everything that is an anomaly in an anomaly class. For example, the X's here could be anomalies and this could be normal, right? For example, and then I just train a model. So I just train a model that detects the red X's. Okay, I could do that. But for this, I would need to know what an anomaly looks like. And here I can just like, for example, cluster. And if there are some entities that maybe are here or here that don't really belong to any other cluster or belong to a small class outside cluster, that I could say, hey, these could be anomalies, right? So I can use basically both approaches for the same task, but the actual data mining goal would be different. So here I would train a model to detect the axis, and here I would actually calculate the distance of the clusters to each other and see what cluster may contain outliers, or maybe an outlier cluster. Or I would use maybe a clustering mechanism that doesn't necessarily put every element in a cluster, right? Like dbScan, for example. If you've ever heard of a cluster mechanism, dbScan, it doesn't necessarily, it's not what we call exhaustive, so it doesn't necessarily put every element into a cluster. And then you can detect like outliers with it, right? So this is the difference, right? So if I ask you in the exam, the difference is, okay, in supervised learning, a training data set is provided with features and with a label, with a target variable y, and we learn based on that. And if we apply in inference, if we applied inference step is then when we use the model on new data that we haven't seen before. So this is training and this is inference, right? So in unsupervised learning, we just provide basically the features, and the model has to find similarities, and applications are, for example, cluster analysis and a real application like market segmentation, customer segmentation. And in supervised learning, yeah, we have all kinds of applications. For example, credit, test whether someone will get a credit or not, loan application, and so on. So there are like millions of applications. So we will see a lot of them. So this is just as a repetition from last time, right? So I want to go a little bit. So I skipped the slide last time in a very fast manner, but since today I have a feeling that we will start with data understanding, as we need to move along a little bit. So I like to talk a lot, but we need to move along. So I kind of feel like today is more appropriate to have like a little more detailed look on what a data table looks like, right? So we talk about data maybe in a couple of minutes, but what I would suggest, so this is like an extra practical advice. So this is not necessarily relating to the theory that we usually learn, but this is like a practical advice. When people talk about like data, training data, try to visualize the data in a data table. Always, if you can, if it's not image data, or if it's like time series musical data or so, even then you can imagine how the data would look like, but we will talk about this when it's appropriate. But usually for the start, you will have data that look like this, right? So I always want you to imagine it in a data table format. Why is this important? Because you will see what kind of columns you will need and what kind of rows, what kind of information is in each row. So what is an object here, right? So here, each object is like a human being, right? We have age, we have weight, we have gender, we have smoking, and all kinds of variables. We will talk in detail about what kind of variables, what are difficulties with these variables. So this is not of a concern now. However, it will look like this, and you will see this part here: age, weight, gender, smoking, job. This is X, right? So this is X. This is the part of the training data set in supervised learning that contains the information that are needed to predict the target variable, heart attack, yes, no. So we separate the data, the training data, in this part and that part, right? But we will give both in the training, right? We will give both. So in supervised learning, we will give this table and then it will be trained. Once we've trained the model, what we will do is we will actually have we will take a new human that comes into the doctor and we will ask, hey, what's your age? What's your weight? What's your gender? Do you smoke? What's your job? Right? And then we can predict the risk of a heart attack. Right? So this is very simple. It's not a perfect model. It's just to get you to the idea. Right? So these are people that we know maybe had a heart attack, right? And now we will want to predict the risk of a heart attack of a new person that comes into the doctor's office, right? So of course we won't know for that person the Y variable. So it's obviously unknown because it's in the future. We're in predictive analytics. So we're in predictive analytics, and from predictive analytics, we are in supervised learning now, right? So you can see it's like we're going a little bit smaller now, supervised learning. And more specifically, in the task of supervised learning, we are in classification. So there are two things: classification, where the variable here that we predict has classes like yes, no, or colors or several options, but this is discrete variable. So it's not unlimited in the domain. Whereas in a regression task, we predict simply a number like stock prices, kilometers, whatever, right? So it's a number. So this is maybe a class, a discrete class. So this is called the classification. But we will talk about this also a lot of times, so you will learn it. So this is the idea, and this is how the data looks like, right? And now in unsupervised learning, what could I do here in unsupervised? Let's say we want to do unsupervised learning. Okay, this is a question for you. In unsupervised learning, which column would I not have here? Let's say I want to do unsupervised learning, which column would not be given to me, or which column would not be available to me if I were to do unsupervised learning. So the last one, the target, exactly. So just make sure, checking in if everybody is awake. So this was an easy one. Okay, and I have a follow-up question for you. Now, let's say I want to do unsupervised learning because we don't talk much about unsupervised learning, right? But now this is the only chance to talk a little bit about this. Now, let's say I want to do unsupervised learning, and of course, I don't have this column, as you all correctly said. Now, what could be the purpose of doing an unsupervised? So what could be a task? Like think about what could I do with the data? Usually we have a task and then we look for the data. But sometimes when you are like in IT, people come to you and say, hey, I want to use AI. What can I do? And then you have to like do it the other way around. It's very cumbersome, but it's also something you occasionally have to do. Like, so what could we do? What could be like an idea of unsupervised learning here when we only have these things, when we only have these columns? What could be an idea, or what's basically the only thing we could do with the data? Find a pattern or trend. Okay, so I wanted to have this answer. So we have, what do we have? We have cluster the data to see concentrations. Okay, look for patterns in the data and group them, find a pattern or trend, study interrelation. Okay, so there are many things here. Really cool. So let me address some of them because as you might have noticed, the wording is somewhat important here. So I'm not like the most correct guy when it comes to wording. So this is a problem for you and for me. I'm gonna be honest with you. However, some things we have to be careful about. So when you ask a question and you write like we look for patterns and trends, this is so general as an answer in the exam, it will usually not be correct, right? So be more specific, like cluster is what we're looking for, like cluster the data, and then you can say cluster the data is the task based on patterns among the variables, like similarity patterns, right? So, and then trend, like find a trend. A trend is always something that has to do with time. We cannot find a trend here. There is no time, There is no timestamp. So when you use the word trend, a trend is always something that has to do with time. There is no way we can find a trend here because there is no time. Because people loosely use the word we can find a trend, right? Trend is something that occurs in time series analysis. We can find a trend like a stock trend, but we have to have time on the x-axis. There's no other way to identify a trend. So what I want to teach you is don't use the word so loosely, right? Try to think about what you actually want to express. So it's not wrong, but you have to see what kind of data you have. Okay, study interrelation. Okay, so you mean correlation? Like for example, what has gender to do with smoking, right? So this wouldn't necessarily be a thing of unsupervised learning, but this would be a thing of data exploration. So this would be a descriptive thing, right? So we wouldn't build anything, but yeah, this would also be interesting. It wouldn't be unsupervised learning, right? It wouldn't be learning at all. It would be, however, descriptive analysis or explorative analysis. So this is what we will do in data understanding. Because for us, it's important how variables work together. So correlation is somewhat of a point, but I have to say, we don't really stress correlation. And you should neither. The correlation thing is sort of a statistical tool, right? So it's sort of like from more of the diagnostic analytics. So we will mention it. It's okay, but don't overdo it with the correlation because we want to give the data into the models and we will train the models and the models should identify everything for us, right? So we are more concerned in training the correct models than having like all these correlation checks. This is somewhat job of statistics. It's cool for you because you don't like everything you learn in statistics, you don't have to bother too much now. Like a little bit, we will bother a little bit with it, specifically data understanding, but not too much now. Okay. So that's the good news. We don't have to go through all the statistics. We will go through some of them, but from a different perspective, like from the perspective of machine learning. Okay, we just went over this, so I don't have to do this again. Like we just went over this using the example. So here, for example, this is like the solution to what I just said. So we can have like some clusters here then, and each object can then be put into a cluster. Okay, so now I just talked about it. This is probably an important thing to do here is that we need to talk a little bit about like I said descriptive analytics. Okay, is rather important. We will need it in data understanding and data preparation. So this is like we need this definitely in our process. So this is like done. Okay, and then prescriptive analytics is kind of what we do in the end. Like we assume that maybe humans will make the decision and we will support the decision. So this is kind of a thing we have to take care of at the beginning in business understanding. We at least need to know what kind of decisions we need to support. Talk about this later then in business understanding. And even more important, we have a thing that is now hanging a little bit between the lines, which is the whole thing with the diagnostic analytics, right? So, and diagnostic analytics and predictive analytics, they kind of use sometimes the same tool set, maybe statistical things, but they are a little bit different. And so this, I will use this time, I will go over it fairly quickly. It's not that important, right? However, I want to go over it so just so you know what statistics, what's machine learning. People say it's different. Sometimes people say it's the same. So some statistician says, "Hey, we've been doing this for 100 years. Welcome to the show." It's a little bit different though. Okay. So specifically the modeling approach. So the techniques, forget about the techniques, it's the approach. So it's what we want to do, right? So as I said, in this course, we focus on predictive modeling. But there's also this explanatory statistical modeling that is used in diagnostic analytics, right? Okay. So, so how is machine learning different from the statistics class you took, right? So this is the basic learning goal for this. I hope you all took a statistics class, right? So this expresses my panic because it's still helpful. So now how do we motivate this? We motivate this by what I said, the techniques, right? The techniques, they usually, when I talk about linear regression, and you saw linear regression, actually in my process. And some of you asked, hey, why do we have linear regression? I already had this in statistics. I don't want to have this. I want to learn machine learning, and you will. So we will have a different approach on training the regression model. It will be totally different. In the end, it will be the same, but it will be a different philosophical approach, right? And a different technical approach. So, but as you said, the linear regression, for example, which is one of the most basic linear models, it's kind of a statistic. You know this from statistics. So you're wondering, why do we have it here? Because we use it in a different mode. We use it in predictive modeling, right? So the question is, if I use like all these tools here also in machine learning, what is different? Why don't I just call it statistics and call it like using statistical models to predict stuff? I could call this class that, but it would not be the same because it's a different concept. And also when we then go to deep learning, it will be very different. But we have to understand the basic concept, the basic idea of learning that I taught you last time with the analogy. And so we have to kind of distinguish it, right? So if you are interested more in that topic, because I said I will go fairly quickly, there is this read number 2. You can read. This is optional. This is purely optional this time. Also, last time it was optional, but it helps you maybe to get a better understanding because we cannot like talk about this for hours, but it might be really cool for you to read it maybe on a train or something or on a rainy day. Okay, so in statistical analysis, what is our basis? So our basis in statistical analysis is somewhat a theory that we read about, a theory that we extended, a theory that we self thought of and want to check. So we have these hypotheses where we say, hey, I think that this and this could be the case, right? So this is the idea of a statistical analysis, right? So, and then what we do is we use the theory and the hypothesis to construct the model. So basically, if we have like, for example, a linear regression where I said this is present in both worlds in statistical and predictive modeling, we need to select the features we put in, right? So here we deeply care about what we put in because we put in these features where we actually want them to have a meaning. Like we want to explore our idea, our theory is, hey, we think that smoking has an influence on your blood pressure. So we put in smoking. But we then also think that age, we theorize based on studies or based on our own mind, we make up that also age could have an influence. So we put these variables in, and the reason we put them in is the theory and our hypothesis. So we have kind of a pre-existing theory that we put in, right? We put in the theory in form of the variables, and we put it into a model. So we construct the model, right? So we construct. This has something to do with that. You can also have like more complex models, like these partial equation models, partially square models, and so on, like these structural equation models. If we have it more complex, but we can also keep it simple, like my example. We have two variables and we want to check their influence on blood pressure, right? And so then we check the model. And so and this is now the important part. When we check the model, we don't, and excuse my language here, I will say it, we don't give a fuck about how good the model actually is. We don't care about it. We simply don't care. We will look at it, but we really don't care about. We only care about our hypothesis and what the influence of the variables onto the blood pressure were, right? So we don't care if the model like predicts or has enough variables to actually explain the blood pressure. We just have an idea that these things will have an influence on the blood pressure. And if we can confirm that, that will be great for us, right? But we don't really care if these two variables can predict the blood pressure, because as we know, there will be a lot of other factors, but we are not at the moment, are not concerned with them, right? So we want to test our hypothesis. Now in machine learning, basically what we do is we're going to take data that we have. We're going to take data that we have. We're going to put it into the model. Like we know we have a problem and The only thing we basically fix is the same thing as here is the target variable. So the target variable in both cases. So here it's called dependent variable, like it depends on other things. And here it's called the target variable. You can see even the difference in naming suggests that we're just like shooting for the target here. We want to predict the target as good as possible, as well as possible. And here, what we want to do is we want to really explain it. We suggest that the variable depends on things. Here, we don't suggest the dependency. It might be there, but it might not be there. So we throw in variables basically, and we look what sticks basically, right? Of course, this is a little bit exaggerated. We can, in some cases, of course, we will hand select the variables, but we will hand select them from the data that we have. We will not like go out of our way and collect the data. We will not ask people. We will not do a survey because here we really need to collect the data that we want to have. So we need to collect like, do you smoke and the age data. And here we look what we have. We might also want to augment the data with external data, like this is possible, but it's for the sake of the prediction, right? So then we select the best model, we train the model. And so what we hear, the idea is that we throw in the variables and we explore how good they predict. But the goal here is a good prediction, and the goal here is testing hypothesis, right? So you can have this right here. So learning a model with high quality, low misclassification rate. We're just interested that the model predicts well. And this is also why the testing is different, right? So the testing is different. So starting point, hypothesis, model by theory. Validation is the significance test with the same data. So this is the importance, the same data. So if you have something to mark this, right? So this is something you have to mark here, the same data. So there is no training. We have a table with values of age and smoking, also of people. And we have for each of the people, each of the persons, we have age and we have whether they smoke. And then we measure their blood pressure. And so we have a significance test, but we use the model on all the data, right? So here, right, our goal is low misclassification rate, but remember what we want to do. We want to predict future instances. So just evaluating the model based on the data that we have is the data that the model was trained on. Now, let's say I give you a mock exam, and we will, of course, have a mock exam for this in January, right? So we will have a mock exam where you can test yourself, where we can speak about what kind of question will there be in the exam. So the difference is in statistics, I actually want to see if you can like reproduce it, and I will let you take the mock exam again in the real exam. You would like that, wouldn't you, right? But actually in predictive modeling, how I validate you is that I give you a mock exam that helps you, in addition to your usual learning process, to learn what kind of tasks and what kind of solutions. But I will have a different exam. So the validation is based on an out of sample data set. So we keep some of the data and then we will test how well the model predicts it, not knowing the answers, right? Because the model training involves giving answers and data, so X and Y. And then we keep some of the data set where we have X and Y, but we take the Y away, put the X into the model spits out the Y, and we compare the ground truth Y that we took away from the model and compare it with the actual, compare the ground truth with the model output. So this is the main difference also in validation. And like this is, of course, like it will be in an exam situation for you. We get a different exam, obviously. So some questions that you've never heard before. And this is why it's called learning, machine learning, because it's also how you learn and how you validate, right? So how we validate your learning. So this basically is how usual learning in the classroom functions, whereas this is a different task, right? So this is a different idea, and it's maybe philosophically and from the task, from the idea, what we want to do, it's different, right? And we will focus on this. So we will have to focus less on theory So we will focus less on hypothesis and less on theory and more on data, like more on this stuff here, more on data that we have, okay? So if you want, so this is the actual paper. So this is read number 2, right? This is a table from read number 2. So this is like between explanatory statistical modeling and predictive analysis, and they also have great examples. So I won't go into detail. If you want, you can read the paper. The paper is very, very good. It's a stable, I think, to understand this. And here you have like model evaluation difference, and it goes a little bit more into detail. Okay. But from time reasons, we're gonna go over other things now. So we're gonna start now with the CRISP-DM process, business understanding. Let's have a look at our CRISP-DM process. So now that we are done with the basics, we are done with the basics. So we know, hey, we want to build AI-based decision support systems, but for this class, we are focusing on predictive modeling, more specifically supervised learning, right? Predictive modeling with machine learning, and from the machine learning, more specific supervised learning. So this process is a general process. You can also apply this to unsupervised learning, right? You can also apply this to all kinds of different analysis projects, right? You can also apply this maybe to prescriptive analytics. Okay, so this is why I needed beforehand to tell you what will be our focus. So our focus, again, predictive analytics with supervised learning, right? These are the two things. So we'll go from the general idea to these two things, and then all our models will, at the end, our goal is to have an AI-based decision support system that uses supervised learning to predict something. That's the idea, okay? And now the easy part starts. We can follow the structure to the end now until the end of the semester. So we'll start with business understanding and go through quickly business understanding. So the texts I have here are the original definitions kind of from the CRISP-DM process. So this is like CRISP-DM. It's from SPSS. You might have heard. It's pretty old, but it's old but gold, what we like to say. So some of these words are kind of old school. I'm sorry for that, but I think the process is very good. It helps us to like depict what we have to do and not only say, oh, we need to build a machine learning model. No, 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 no. We have to do a lot of things. And what people always miss is the business understanding. And this is why we will talk about it. Because we're at an economics faculty, you try to optimize business decisions, you try to make good decisions, you try to make good predictive models, but it needs to be connected to the actual task. So you cannot just build a predictive model that has nothing to do with the actual task. And this is where business understanding comes in. It connects the business task with the actual analytical task. So your job in business understanding is to determine what we call it. This is one of the old school terms, a data mining goal. You can also call it analytics goal, whatever. So this is the specific goal. So you have to translate the business objective into an analytics goal. So at the end, you have to know, hey, we want to build the system that can do that, right? And you also, before you can say, okay, we need to build a system and the system needs to consist of these components, you also need to assess the situation in between and see what you actually have. Because you cannot say, okay, we need to do this. So this is what we need to do. This is what we have. And now this is what we actually will do, right? So this is what we can actually do in terms of a technical model, right? And then you produce a project plan. I guess this is just documentation. So these are the steps. Let's go through them a little bit. So first step, determine business objective. So of course you need to learn about the background, right? So is it the medical background? Is it the manufacturing background? So for example, let's say you want to produce, let's stick with the example that we had in the beginning. You want to produce solar wafers, right? So you are in a company that has data science experts, and you are sent into the company that produces or manufactures solar wafers that can be put on roofs, and then you can get the electricity, and you can charge your Tesla and so on, you know. But you need these solar panels on the roof, okay? So, and there is a company that, on the one hand, that produces them, manufactures them, and you are sent into the company, and they have a task for you. So the first thing they will talk to you and say, oh, our problem is that we have a lot of solar panels in the manufacturing process when we do quality control, and we do it like we do just average quality controls that are faulty, right? Sometimes they are faulty, and that means we waste a lot of material, a lot of input material in the production process. And what we want to do is we want to minimize that. So we installed a camera that can actually look at the solar wafers at every possible point in the manufacturing process, right? So this is the background that you get, right? And now we want an automatic tool that detects errors so that we can either fix the errors or that we can throw them away to not waste any more time on the further manufacturing process that will either work on wafers that are not that are broken anyway, or that need other things to be fixed. So they cannot continue with the normal production process, but they have to be fixed by manual work, and then they can maybe put back or whatever. So this is the background, and this is the business objective. So business objective is they want to automate error detection so that they can make decisions. So either throw it away or repair it, right? If something is broken. And if it's not broken, it goes straight on the normal machine. So basically, the business goal would be business objective in my example here. Example, solar panel. So the idea is that we have a solar panel and the decision. So the goal, the decision is that they want to make. So you always have to connect the business with the decision. Is they can have like 3 decisions basically. They can manufacture normally. They can continue manufacturing. They can throw it out, or they can repair. Right? So they can repair. And this, of course, the decision depends on of the status, right? So it depends on the status. Status decision. And the status is what we need to determine by the modeling. So the output of the modeling is to give a status, and then we can make a decision, right? So we can either do A1, A2, or A3. But before that, we have to predict status, right? We have to predict the status. And the status prediction, this is our model, right? That we will produce. So, and this is like also the success criteria is that we produce less broken panels. Okay? So we've done this right now. Okay, and now we have to assess the situation. So what do we have, right? What do we have to assess the situation? So we have an inventory of resources. So this basically the inventory of resources, again, the example, here's the example, continue example. It's the same solar panels. So inventory of resources, right? Inventory of resources is basically data or technology to get data. So this is like the database they have, and this would be here more interesting, the camera they just installed, right? Camera, so we get image data, right? So, all right. So then requirements, assumptions, and constraints. Okay, now your task. You know the background. I just told you the background. So in the background, they will tell you about the manufacturing process of the solar panels. So I will tell you a little bit more. So the production is that they start with some material and they have like, let's say they have like 10 production steps. And in each of these steps is a camera, right? And so you can like add this like background. Like they have a production step. This is step 1. And they have a camera here. Camera 1, step 1, step 2, camera 2, and so on. Right? Until camera 10 in step 10. Right? It's pretty easy. So they give the raw materials in, and here out comes the panel. So this is the manufacturing process. Okay. So this is the background they will tell you. This is the background you will need to ask them. Okay. And now I ask you, what kind of requirements, assumptions, and or constraints could be there for the thing I need to produce? And remember, the thing I want to produce is an automated tool. We produce an AI-based decision support system, right? So the system, what the system does is it predicts the status and then automatically chooses one of these actions, right? So it predicts the status and it either is fine. If the status is fine, it will go to manufacturing. If the status is it's really, really broken, then we're gonna throw it out. And if the status is it's a little bit broken, we can repair it. It's just my words. We will have more detail. It will be more detailed than that, but just keep it simple for now, right? So status can have 3 variables, and based on these variables that it can spit out, based on the prediction, we will have these 3 actions. Okay, so this also shows you how to combine prescriptive, because the decision is what you will hear in the business objective realm, right? Okay, so now this production process, I've detailed it a little bit. Now, what kind of requirements, assumptions, and constraints? And it's a simple. So there are maybe some constraints, assumptions, and requirements, but I want to know from you now, based off what you've heard from me, what would be some requirements, constraints, or assumptions that I will need to have? Or can also say, what do I need to inquire? What do I need to ask them about the process, right? So think about it. It's analytical thinking right now. It's analytical thinking training. Very important. Look at the process, right? You should look at the process, how the process works, right? So we have a station, we have a camera. Station, we have a camera, right? So the first thing you should ask yourself is, where is our system implemented, right? Where's our system implemented? So this could be an assumption. So I haven't talked about that yet. So where's the system implemented and what are some constraints, right? So we can have like this little marker, can have like green. Our system will be green. So our model, our system that will be deployed will be green. So AI, I'm going to call it AI system. And where do we put the system? So I'm asking you, think about it. Like, what kind of requirements, assumptions, and so on. So one of the assumptions is, where do I put the system? And based on that, you can derive some requirements and constraints. So think about this. Look at the process and think about what the system does. So what does the system do? It determines the status, right? And then also, where do I make the decisions, right? So I have a process and here I have a snapshot. And now I need to combine them, but you have to do it. You need to think about this. Where do I make, the first thing you should ask yourself is, where do I make this decision? Where do I make this decision? To continue manufacturing, to throw it out, or to repair it? Where do I make this decision? And then you know where do I need to implement the system? It's business to technique, business to machine learning, right? Okay, come on, guys. Use the chat. There are no wrong answers here. Come on. Where do I put the system? Do I put it here? Do I put it here? I put it here. Where do I put it in the process? Where should the system work? Like the system, what kind of data does the system actually take? Maybe you can answer that. What kind of data is the system based on? Yes, image data. Yeah, of course, we have a camera, right? So we have a camera, right? So we have a camera right here. We have a camera right here. Image training data for historical production processes. Yes, this is what is. So where do I put the system? Where do I deploy the system? So the system is trained based on historical image production data. It could also have some other data like temperature and so it doesn't only need to have image data, right? So it could be more data. It could be like data from the station and data from the camera. It could be both, right? Actually. So let's say it takes both. So we know that this is the input for the AI system. Correct. The system should ideally be in the beginning of the production so we can decide in the start, right? Okay, so you would put the system after the first step where we had the camera, scan it here. So we put the AI system here, and then the AI system determines the decision right here, right? Decision, makes the decision. Deck. Okay. So the thing is, I would put the system after every step. So actually the system will be at the end of each step. Yeah, exactly. So because this is why I used words like continue manufacturing, right? So we need to decide after each step is because each step modifies the panel, right? So, and the system will look at it and will say, okay, we have the data, we have the image, we have the data, and the data will be similar. So the image will have different errors, different kind of things, but the system that we train, the model that we train can determine what kind of things went wrong. What I could also do, and this is like a practical advice again, that is not relevant for the exam, but it's a practical advice. I can train multiple models for the system. I can train a model for each step, basically, right? I can train M1, M2. If necessary, I can train 10 models that are using, like, for example, this model here uses the camera 10, image, and it uses the station 10 data like the temperature, vibration. Maybe there's other data, maybe they differ in data that I have. So I could also do that, right? But you see, it was very difficult for you now thinking about these things. This is because usually we start by teaching students just how to do a neural network. And oh, yeah, what is the practical benefit? That's an excellent question. Winston. Okay, let me show you. Now here you have the manufacturing process, right? So the manufacturing process consists of like 10 stations, right? And so now at this moment, we have two options. We can have like one system that checks in the data and the image data from the camera, right? And we treat every station the same, right? So this would be one model. We have one model, so we have just one model, and the model is able to put out a status for all of these, right? So, okay. The problem here is I can definitely do that, right? However, there are several things that can happen here. Now, the first thing is let's say, where would one model work, right? One model would work well if we really had the same data for all the stations, right? So the data would have all the same variables, right? So we have a data table, and the data table for station 1 has like the temperature, like vibration, and some other variables, right? And these would be the same for S1, S2, and S10. So the same variables. The table would look the same. And also, very important, so this is for the data from the station and also for the camera data, like this would mean that the images like could potentially have the same classes of mistakes. So for example, maybe there is a tear here, right? So this would mean that there is this would mean that there's error 1. Then let's say you have like 10 types of errors, right? Or let's say you have five types of errors. So this is error. Maybe here there is a crack. This is error 5. Maybe here there is a shadow. This is error type 2. And they would be the same after each step. Then I could actually use one model. But now, if let's say the production process is somewhat different. So we have here, it does like some steps, and the potential errors that camera 1 recalls is very different to the things that camera 3 or 4 can recall, because it's a different layer. Let's say there are a lot of different layers, and so the errors are different. Now, if I have one model, I would have one model that detects all the different errors that can happen in C1, C2, C3 to C10. It is possible, but detecting like an error based on 2 data sets, right? We have the data from the camera and the data from the machine. And then we have a lot of error classes, right? We have a lot of error classes. So if we have one model and we are in step 3, for example, I would also need the error, if it's one model, I would need the error classes from step 1, step 2, and also step 4, 5, 6, 7, 8, 9, 10, right? And this is not relevant to the station. And also, it would complicate things, right? Because I would need, like, I had a lot of instances where I don't even have this combination and the error because I have different data. Now, if this data also differs, then basically the stations are more or less independent. So if they have nothing in common, it makes no sense to have one model. Now, if the errors are pretty much the same or the same type, so I can somehow determine the errors, then this would make sense to have one model. Like we have one model for everything, right? Because then we have more data and we have the same kind of idea, the same errors, the same things that lead to errors. So this is the benefit of having several models. And now Tim asks, would I train 10 standalone models? So would they be connected by one master model for the whole production? I know it would be 10 models, and the model input of the previous model would be an input for the next model. So of course, now let's say in this case, if I do the decision, if I make the decision in every step, then it would be standalone only because I make a decision, right? So I make a decision. So I make the decision to continue manufacture, then it will go from station 1 to station 2, right? Because I make the decision to continue manufacturing. If I make the decision to throw it out, it will be thrown out and never heard of again. If I make the decision to repair, then it would be repaired, and then it could continue. Now, 2 things I could do here. I could totally ignore the information that it has been repaired, or that it's or I could ignore the status, like if this is a number, I can ignore the previous status and just put it in, or I can like give the status into the model. Like there could be a variable in C2 that says previous status. And this could be like fine. So this is like when it was like continue manufacturing, or it could be repair. It won't be throw away because if it's thrown out, then I don't have it, right? So does having multiple models increase the probability of overfitting? No, because each model is trained separately, right? Each model is trained separately. So it doesn't have any, if they are independent, then no, because overfitting occurs in the training of one model. Now, if I have like one model and they are similar, right? Then I would still have like a little bit different ideas on how these things work. Like if I have similar models, because I would check each of these models. The only thing that occurs, it wouldn't cause overfitting, but I would need to evaluate these models by having like training and test data for each of these models, right? So this is important. I will deal, and also the advantage of having one model is I only have to train one model and have to address all the problems of this one model, like data preparation, modeling, like things like overfitting. I would only have to do it once, right? I have to address this once. Now here I have to address this 10 times, but it might be a better result at the end, right? So but we will learn more about this later on. So as it stands now, in this easy thing, the models, if I train different models, the models would totally be independent from each other. The only thing left would maybe have given a model input into the next model, like the decision that we make. So they know, okay, it has been repaired. Because you can imagine if it has been repaired, the difficulty could be here that the repair was not good, or maybe something can go wrong, or there's an increased risk of failure at some of these points. All right. So, but what I want to know, so this was very elaborate, but actually I asked you a question, and that is, now that we know where to put the system, what kind of, so the assumption is we put a system after each step. So we have step 1, and so step C1, camera 1. In step 1, we put this into AI system 1 and AI system 1. So we start, then we go here, right? And we put it in AI system 1, then we make a decision, either continue or not. And then we have camera 2, step 2, and we have AI 2, and it goes on, right? And AI checks the whole thing and it puts it here, right? So, and then we either go on or so, and so on. Okay, now what assumption? So this is the assumption we have, and the requirements, requirements or the constraints. So it's kind of if there are constraints, that depicts the requirements, right? So the requirements can be derived from constraints. So now I'm interested in requirements and constraints. Think about the manufacturing process. How does it look like? Like, visualize it. What do I mean by station 1? What is it? What is this? What is the production? How does the production, how is it operationalized? Now I say step 1, step 2, but what does it look like? Yeah, a production line. Like, let's assume there is a conveyor belt. So it goes on here, and then it goes to step 2, and it goes to step 3. Then it looks different, and then it goes to step 3, and it looks even more different. So, okay, perfect. Yeah, correct, Ahmed. Production line. Now, shoot. What is requirements and constraints here? Because, you know, we have the model in here, right? Model is here. Model is here. We just made this. This is an assumption we just made. Model is here. And decides. Now, what is a requirement? What is a constraint? Now, what is this? This is a conveyor belt. What does a conveyor belt do? You're thinking too hard. You're thinking like already like overfitting master models and all these things. This is quite nice, but you're thinking way too complicated. You need to think very, very simple. You need to disenfranchise your brain from the class. This is not about machine learning. This is about thinking logically. We're in business understanding. You have to first and foremost understand the business. We don't care about machine learning right now. We really don't. We just care about if we had a system. We don't know what to do the system. Where would it be? Where does it need to be? And what are some constraints and what are some requirements? The conveyor belt moves the product from one station to another. Yes, Tim. And what does it mean? Move. It moves. It moves. Moves, moves, moves. It moves from one station to another. Exactly. This is the simple thing I was looking for. And what is the implication if something moves? When do I make my decision? When do I make the decision to throw it out, to repair it, or to continue to the next station? You need to get to it by yourself. This is more important than teaching you other things. This is like really important. This is analytical thinking. This is business understanding you need after the previous station. Yeah, if the requirements are met. Yeah, if the requirements, so the requirements are checked by the AI, right? So the AI checks after the step, and then, as Tim said, after the previous station, right? So after the previous station, it will get checked. But what is this? It's a conveyor belt, right? It moves. What does moving mean? It moves. Like in the production, okay? I want to produce things. So let's say in one day, I want to produce, yes, progress, yes. It doesn't have to stop. Yes. What does it mean what does it mean for my decision? Like, what does it mean? We need to track it. Yeah, we do track it with the AI, but I know the idea. We need to track it. Yes, that's it. The system needs to be quick. Avoid downtime. Yeah, also either avoid downtime, the system needs to be quick. So continuous production. Yes, you're getting it now. So this is it. The system. So we can have two things happening here. So Johannes said avoid downtime, which is correct. So either I stop the system here, I stop the system at each step to let my model check it, right? But the longer the model takes, right, the more stops I have. So I have 10 stops of like, let's say the model takes 2 minutes. It will 2 minutes for each step. It will hurt my whole production process, and we don't know what happens before that. Like there are some preparations here as well, and there are some things happening afterwards. So if this process takes longer, everything needs to be smooth. Exactly. So, and after all you've said, what is my requirement for the AI-based decision support system? Now that you've said all this and we've spoken about this, what is the requirement? Plain and simple. What is the requirement for the system, or what kind of requirement do I have? Now, not the training. I can train it, continue, throw, or repair. That is not the requirement. That is the decision that is made based on the system. But what is the requirement? So, Umar, you say continue, throw, or repair. This is the decision I make. So the requirement is that I have to make this decision before I can continue. Must be as fast as possible. That is correct. Speed shouldn't interfere with the production. Everything is correct. Short, accurate decision time to avoid downtime. It's broken on. Yeah. So, correct. So the decision that either we make or the system makes doesn't matter. We know that the AI-based decision support system gives the status, and the decision is made based on the status. So we need the system needs to be fast, right? So the constraint, requirements, and assumptions is time. Time of, and this is what we call the time that the model takes when it encounters new data to put out a prediction is called, and this you should remember. I will write it so that you can actually read it this time. Inference. Inference, yeah. Inference. So this whole thing is called inference time. So inference time needs to be low, right? The inference time is not the training time. So we train the model, then we deploy it. Then if we have a lot of data, we can retrain the model on weekends, but the time the model actually in a live deployment, the model takes to classify the status, so to say, okay, this is either very, very kaput, yeah, or this can continue, and so on. So to determine the status, to classify it into these three classes, right? Into these three classes that we have, the status, right? And then make the decision based on the status, right? So the status is broken, less broken, or completely fine, right? And then you have these decisions, right? So That needs to happen fast. And we got it. We got there together. And now you see how business understanding works. While you might be annoyed that we took so much time out of the lecture today, this is a crucial thing because it's not really something you can teach with a slide business understanding. It's something where you need to know, okay, this is the business case and what do we think of? And there may be other things we need to think of, right? Like, for example, what happens before? Like, we need to look at the whole production thing. Does it really matter? And then we can determine actually what, for example, a maximum inference time is. So we can actually determine like a constraint. We can actually have the constraint max inference time, right? And the maximum inference time could be, for example, 1 second, right? So as an example. And this is a result we need to determine here and assess the situation. And then risk and contingencies. Now, risk and contingency says, okay, hey, listen, what happens? What happens, just as one example, you should also think of more like after the lecture, go home, relax, or you are already at home, drink a cup of coffee, tea, whatever, go outside and think about more requirements and assumptions, more risks, more terminology. Good terminology is like, don't have to think of it. It's like more from the background, like what's the terminology that we use here. Also costs and benefits are also derived a lot from the business objective, but risk and contingencies means, okay, mainly what happens if your AI is bullshit? What if your AI has a risk of predicting wrong things in the live environment, right? So we can test kind of, if you use the test data set and we have some stability measures, we will talk about this in the evaluation section a lot. But what happens if the AI says, because what you do is you automate it. And let's say you also automate the decision. So the system could also like send a signal to a robot. So let's say there is a second system, right? A robot, there's a robot system. And the robot system is a red system. And there's a robot system here. So there's like a hand, a robot hand, right? And the robot arm gets the AI status, right? The AI status, and then the robot arm executes the decision and says A1, A2, or A3. So the robot arm sorts it either in the bin or puts it into the next station or puts it on a separate space where it can get repaired in a repair pile, right? So, and what are the risks and contingency of that, right? So the benefits, the costs and benefits is we can calculate, like what does the system cost, the AI system, like the risk and contingency. So we can also say what happens if this goes horribly wrong. So we have some risk, maybe a small risk that the whole system, that the whole manufacturing plant will stop and so on. And yeah, so the terminology, yeah, we get from backgrounds. Don't know why it's really here. It's not that important, but these 4 things are really important, right? So, but this is like how you need to approach it. And also, for example, usually you don't have to determine this by yourself, but they will say, hey, we have this robot arm and we want to use it, or we don't have this. So this is something you get from the inventory of resources also. So for example, do they have the robot arm or not, right? So who does the decision? Like also inventory resources is also human resources. How many people do they have? Like if they only have one person that checks in like 1 hour out of 24, makes the quality control, then costs and benefits could grow. It depends. Or do you have a scenario where it's already really good and you want to get rid of a lot of people? Like, what's the benefit of that? Like, you get rid of a lot of people is maybe not that good, and maybe you won't save a lot of costs. And yeah, so it's a cost and benefit, not only what the AI system costs, but what you can like save and what are your benefits. So this is like that's why it's called business understanding. So we have to do some calculation as well, right? Okay, then and then we're gonna translate this whole thing into a data mining goal, right? So we kind of already did that, to be honest. Like we kind of already did this right here. So this actually is the data mining goal. So we know the decisions. Maybe I can do it clean. once again. So we know the business goal, right? So we know the business goal, and hence we know the decisions. Like from the business goal, like from the business objective, we actually know like, okay, these are the possible decisions that we have, right? So we have A1, A2, A3. Of course, they won't call it A1, A2, and A3. They would just say, hey, we want to know if we what to throw away, and we have the system. Like we have these 10 categories. In my case, there are 3 categories. So we have fine, it continues. 2, it gets repaired, and 3, it gets thrown out the garbage bin. So here it gets repaired by the robot arm or by a repair guy. And here it just continues to on the manufacturing belt, on the conveyor belt, right? So this is something we know from the business. This is how they handle. This is how they handle it until now. Now it could also be that if you put the AI in, that it will that the business understanding will change, right? So don't ignore that. Like this model suggests that it won't change, but as I said, so we could, for example, suggest, hey, buy a robot arm. It will be then the benefits will be much more heavier than when you don't buy a robot arm, right? So it's just a suggestion. But usually they give you some business objective, and then you will have to determine, okay, how can we support that decision? So the data mining goal would then be a classification. It would be a classification that helps to decide AI, but the small, like the decision to make decision to decide to make a decision AI based on this decision set that we have, right? So, and we say this is a classification. We could also say, what else could we do? We could also say we have a regression and have like a fit score of a piece. We could like have like a fit score, right? Or we can have like what is called uh, sometimes we can have other things. Like if this was not a production feature, but a maintenance, if this was a maintenance case, which is not, this is why it's optional, like remaining useful life or other thing. Like we could have a fit score from 0 to 100. We can assign, we can build a model. But then again, it's hard to get training data, right? Because we need to like calculate the fit score based on other statistics that are in the past that we have. So we need data for that. Like, do we have data for that? But that we already have in assess situation, right? So this is why these things build on each other. So we can determine data mining goal. We can say, okay, we can do a regression with a fit score because we have the data where we can like calculate the score. We have to just make a classification, have some classes, and they will then lead to either A1, A2, or A3, right? So something like that. Also, I said there are 3 classes that actually fit with these 3 decisions. I could also have like 10 classes. For example, I could just use the solar wafer optical detection, and I have 10 error classes, so A1 to E10, and then I will determine based on the errors what action to do, right? So it could be that E1 to E3 is not that hard of an error, so I can continue. If there's no error, I can only continue when there's no error. And E1 and E2 is like repairable, and the rest, like E3 to E10, is not repairable. So I will then have some kind of this thing. But this is all the things I have to determine here, right? And this is really important. Okay, so and data mining success criteria is basically usually the quality of the model, right? So the success criteria also some things that where we see, okay, what do we need? So sometimes this is connected to this. So what do we need? The data mining success depends, for example, that I have data for the fit score, that it doesn't change, right? That I have usually it says, okay, we need the successful criteria, but also something so anecdotal advice. This could also be like, what's the risk of a concept drift? Concept drift. Does anybody know what the concept drift is? Can somebody tell me? You can also Google it and be a cool guy or a cool girl that writes and say, hey, I know what it is, but you just Googled it, but it's fine. What's a concept drift? It's a pretty important concept. Excuse the pun, but yeah, it is kind of an important thing that you have to think of before. Like how likely is a concept drift? Because the whole thing, like it determines, for example, how often do you need to deploy it? How often do you need to retrain the model? So this is like not a one-time thing. Like this is obviously done over and over again, right? And sometimes I even have to go back to business understanding. So for example, this right here is done a lot, right? So you can do this like every weekend. For example, you retrain the model with the newest data, so it gets more robust, and also it will take care of concept drifts. Does anybody know what a concept drift is? A concept drift means that your data generating process. So in our case, the data generating process is our manufacturing, the manufacturing. So we have camera data and we have other data like temperature. So this is all we have, right? In our simple example. Now, a concept drift says that our data generating process, so basically the manufacturing process, because this is what causes the data that we observe, like it causes the temperature, that it changes. Now, for example, let's say we build in new machines. We exchange step 4 and step 5 are now together in one machine. Let's call them machine step 4, 5. That's a new machine. Like this could be a concept drift, right? So because then we have different data, we have a different production. So if the production changes, it could be subject to concept drift, also means the data changes, and then our old models will not work anymore. So where this is in-house here, I basically know. So I have a new machine. I think about training a new model, maybe going back to data understanding, data preparation. All right. But sometimes I have data that comes from customers, like from the outside, from things I cannot touch, right? So where I cannot influence it. I cannot influence my customers. I cannot influence the market. I cannot influence so many factors. And now if I use data for this, for example, I project if a product will go well or not, right? So a lot of models do that. They project the product success of a model. In marketing, we have that, right? And they use increasingly more machine learning models for that also. Now, the problem is there's a lot of data I cannot influence. Now, here I can basically see that the data generating process would be changed by having a new machine that has maybe new data standards that combines two machines. So it could potentially change. But I don't necessarily get it when my customer base changes. So for example, classical business concept that you might have heard is like the classical TV. Like you can see that everybody goes to streaming and everybody then goes from streaming to like TikTok and shorter concentration spans like Instagram, TikTok, whatever. So this is how people actually nowadays get entertained, right? And now if you don't get that concept drift, right? And you predict things based on an old model where TV is the prime source. This is a very critical thing because the concept drift oftentimes takes years to like manifest. This is not, but it can also be a concept drift that happens from one day to another. It depends, but usually it takes a longer time to transform the underlying data generating process. But all the input you get suddenly from the TV, from people that watch TV is not relevant anymore, right? And you're wondering why you're not selling your products, for example, because, well, everybody's on TikTok and you need to like go on there and you need to take the opinions from there, for example, right? So there's a concept drift in the data. The data generating process changes, and therefore the value of your data that you have changes. Like just in the manufacturing process, it would change, right? If my data would be less valuable because I now have a new machine, and so the data from that machine in the old concept, right, in this concept here, or this concept would not be worth much because it doesn't necessarily says the same that my old model uses. Okay, so very important concept. Then we basically end with project plan, obviously. So this is just project management, initial assessment of tools and techniques. So this is also pretty important. How do I want to do it? Like, do I want it? And this is kind of important. Why is this important that I say, okay, why is this important, and why does like access as a situation influences also this, right? Specifically this. Like now I want to do a little bit, not computer science with you, but a little bit of information systems, where it's the field which I come from. But why is this important? Like not only what I do, but think about this step. I want you to think about this step right here. Think about this together with this right now. Why is this important? You need to think we're still in business understanding, right? So what's the overall goal? What will happen? So you need to picture what will in the end, what will the customer have? What will we give the customer? This is the important thing. And people tend to lose it, right? Don't lose the actual thing you want to produce, right? Which is an AI-based decision support system, right? This is what you're producing here. So what is an important aspect of that? How the customer uses the decision support system. That is very important. Like that is very, very important. So what kind of system, like when we talk about a system, right? So let me give you a final thing here. So a system is like a house, right? This is our AI system, right? This is our AI system that we produce, right? This is like a house. And in the house, there is my machine learning model, right? This is what I train. This is what comes from modeling and deployment, right? This is the result, is not the system, but it's the core of the system. Without the system, the house doesn't work, right? So it's the foundation of the house, maybe. Foundation, it's the heating, whatever. It has everything important. It's the power for the house, the heating for the house, the foundation. Okay. But then there's also like the customer needs to use it, right? So there's maybe some web interface here that the customer can use, and then there are people in the office of the customer, right, that use the AI system, like Tristan said. So they're using the system, and they're using the system based on this interface, right? So there is an interface here. Okay, they use it. So it's important to see how they use it and whether they trust it or not, right? But there's another thing that is important, right? This system is not isolated. This system cannot be isolated. What does the system need? Specifically this. What does it need? Is this isolated? Is this an isolated house? It cannot be. What does it need? What does the system need? What does the system need? It needs to be connected to the client's internal. Exactly. So it needs to be connected to other houses that the client already have, other systems. Like, for example, the database or the data warehousing system. It could be even different, right? It could be even different systems, different houses, wherever they are, the ERP system, right? So this needs to be connected to all these systems. And then, of course, it needs to be then integrated into the whole IT landscape, like security and so on. Everything needs to be integrated. So just that you know that this is not just like, oh, initial assessment of tools and techniques, blah, blah, blah. No, this needs to be compatible. So what kind of tool do I need? Can I use a Python? Do I need to program it in C#? What's the kind of language I can use? What's the kind of tool I can produce that is within the constraints of their security standards? Right? So this determines my initial assessment of tools and techniques, right? So very important. With that, we have done with business understanding. So we are actually very punctual today. So I hope it didn't bother you that we spent a little more time on that, because it's a step that usually gets neglected. people don't care about that step, right? Everybody cares just about modeling, and we will dive into modeling. Don't worry about it. So, but I quite find this step really important because without this step, none of this will work. If you don't understand what you need to do, it's like in an exam. I give you a question, you basically know the answer, but you don't understand the question, so cannot give me the answer, although you would have known it, right? So I want you to imagine that this is like that, okay? So next time we're going to talk about data understanding. Next lecture will be data understanding. Then we will move on based on that data preparation. Then we will spend a lot of time on modeling, then evaluation. And yeah, then this will be it for the semester. So very chill semester. I hope this is okay with you. And I hope it's okay that I sometimes spend a little bit more time on the steps that usually get not covered, right? So because you can read a lot about also modeling and other things on the internet, but this is kind of a thing that is very much should be subject of a class that talks about AI-based decision support systems. Okay, with that, thank you so much for, let's say tuning in. As always, I will upload the VOD version, and if you're watching this on VOD, you already have the version. So now it's time for your question. Thank you so much. See you next week.